Hi everyone. We are continuing our discussion on triangles, and that is a discussion that is going to be continued for quite some time. It's the focus of this unit, the next unit, and the next unit, and even then we'll still be talking about them for the rest of the year. So triangles are a shape that come up quite a bit. Today we're going to be talking about a couple specific types of triangles. We're going to be talking about isosceles and equilateral. And hopefully you remember from a couple of lessons ago that isosceles means that I've got two sides that are congruent to each other, and I've got three sides that are congruent to each other for equilateral. I'm going to do a lot of stuff that I need to do right now. Alright? So, looking at these two, we know I've got an isosceles here and an equilateral here. The important piece of information that we're kind of not adding today, because we've had it, but that we'll be focusing on today, is that if these two sides are congruent, as indicated by these hash marks, remember that's what those hash marks mean, that those two sides are congruent, then their opposite angles are going to be congruent. Remember, opposite means on the other side. Okay? So, on the other side of this side, we're looking for an opposite angle. The angle that's farthest away from this side is this guy over here. And then the angle that's the farthest away from this side is this angle over here. So these two sides are congruent. Therefore, these two angles will also be congruent. Okay? Another way you can think of opposite might be what angle is not made up by that side. Okay? So if I said this side has nothing to do with that angle. But both of these two sides do. Okay? So if you're looking at an angle and wondering, okay, what side is opposite an angle? It's the side that doesn't make the angle. Same thing for a side. If I'm looking at what angle is opposite, it's the angle made by the other two sides. Okay? So that's going to be really important. Because that means that we can solve problems like if I say that this is a, let's say, 80-degree angle, I can solve for the other two angles because I know that they're congruent to each other. So that means that I've got 100 degrees left over. Remember, all of the angles added together in a triangle are 180. 80 of them are already taken up. So I've got 100 left to distribute between those two. Because they are distributed evenly, I can divide by 2, and both of these will be 50-degree angles. Okay? So, that should hopefully make solving some of these triangles a little easier and also possible in some cases. It could also go the other way around. If I give you, let's say, a 30 here, because you know that these two angles are congruent, you know that this is also 30. And 30 and 30 is 60, which leaves 120 degrees for this angle up top. Okay? Now, an important piece with isosceles triangles is the converse is also true. So we know that if two sides are congruent of a triangle, then their opposite angles will be congruent to each other. The converse is true, which is you flip that, which means if two angles of a triangle are congruent, then their opposite sides are also congruent to each other. So if I give you two angles that are congruent, we know that those two sides will be congruent to each other. Now, that does not mean that they can't also be congruent to the third side. And that's important. All it means is these two sides are congruent. It doesn't tell us anything about that side. And I'll tell you why that's important as we move on to equilateral triangles. Now, equilateral triangles, remember, mean that all three sides are the same. The important point there is, if all three sides are the same, all three angles are the same. Remember, these arcs mean that we're congruent, just like these dashes mean we're congruent. So if you have an equilateral triangle, you also have an equiangular triangle. Okay? And here's what's interesting about equilateral triangles, is there's only one possible measurement for these angles. And that's that they all are 60. Because if I have 3 congruent angles, and I have 180 possible degrees for those angles, when I divide by 3, I get 60. So all equilateral and equiangular triangles have 3 60-degree angles. So let's do just a couple practice problems here, and then get you going. So I give you a triangle, and I say this is a side measurement of 13, and this is a side measurement of 13, and these two angles are congruent. Is it possible to find x? I'm not asking you to find it yet. I'm just asking, is it possible to find x? Well, what we know about isosceles triangles is if I have 2 congruent angles, then the opposite sides must be congruent. Opposite of this angle, so we're looking for a side that is opposite, is this guy. Opposite this angle, or the side that does not make up this angle at all, is this one. So I know that these two are going to be congruent. So x is 13. Not only that, but because I know that this is 13, and this is a 13, and the third side is also 13, I know that all of my sides are congruent, which means all of my angles are congruent. And I have an equilateral triangle, which means all of my angles will also be 60 degrees. Okay? Let's look at just a couple more here. Looking at this triangle that we have created with 2, if you make the point clear, we've got 2 parallel lines, we've got transversals here. Can we solve for missing sides and missing angles? Find the rest of, let's find the rest of the angles. Knowing that this is 45, we're going to use our vertical angles. Remember, vertical means on the opposite side of the intersection. I promise you vertical angles are not going away. You have to have those down. So if this is 45, then this is 45. Because these two sides are the same, I know that this is an isosceles triangle, which means their opposite angles will also be the same, which means this will also be 45 because I know that these two angles are going to be congruent. And then I know if this is 45 and this is 45, I have 90 degrees left over for this angle. Something that I would like to make note of is that isosceles triangles can be right triangles. They can have right angles. An equilateral triangle cannot be a right triangle because we just don't have enough degrees. Okay? If all of the angles are the same, and I have to have a right angle, then all of the angles would have to be 90, and then the triangle is not going to close, assuming that we're operating on a flat surface. So it's not going to work for us. Okay? So those are the kind of things that we're going to be looking at today. Homework is getting